when it comes to the other type of cloning that we have here, we have reproductive cloning. This was something that was basically impossible to do, getting a multicellular organism to be copied entirely. Very difficult to do, very hard to do. And we were finding out there are various different types of stem cells. And depending upon the stem cells that were utilized, depended upon the potential outcome of reproductive cloning. There is and I think I have a reference to it here in a little bit, I think. It's called the God cells. And it's a pretty fascinating documentary. It kind of is. We'll get to it here in a second. But in that God cell, it does a fascinating job of telling you just the billions of dollars that these pharmaceutical companies put into research and the hoops that you have to jump through here in the United States when it comes to that. And it looks at a stem cell clinic overseas in Russia somewhere. So it's pretty fascinating. The unfortunate part of it is the documenter, he injects himself into the conversation, which he probably shouldn't have, and starts getting some of the stem cell treatments. I think there's a clinic down in Mexico too, where they do some stem cell treatment. But I don't know. I don't know how safe that is. Russia and Mexico aren't the beakiness of safety. All right. So let's veer back on the track here. I got off on a huge tangent. I apologize. All right. So what is reproductive cloning? Well, in sex, right, we have mom and dad hook up, fertilize, sperm and egg, and, they're both haploid, and then they come together and give us something diploid, right? That zygote. So, I mean, this is something that we've already kind of talked about. So it's pretty interesting how they do this here. You can't just take any two cells. There's things in an egg cell that are necessary. The egg, when it goes through its divisions, has all those polar bodies, and they help to provide some sustenance and nutrition to that surviving egg, or to that egg that goes to fertilization or potential fertilization, goes to ovulation, I guess is the best way to say it. And we don't exactly know 100% as to what exactly it does, but we know it does some bunch of stuff. So you can't just take like any egg. You can't just take any cell in the body and copy a whole individual from it. How easy would that be, though, right? To do reproductive cloning, they found that you need to have a diploid cell. Okay, it can't be a haploid cell. It's got to be diploid. Okay. This is so interesting and it's so complex. I'm really trying to just make it so basic for us here, because it's kind of interesting to know. And this is something that's going to be a lot more prevalent in the future. They've already talked about it with various different genome projects. I think I have a video here, I think towards the end, where they talk about some of the medical applications of all this. So it is something that you're going to have to understand, because it's something that Congress has already made some laws for, and you should be aware of. And those laws can affect access to different things, people access to different things, people having access to your genetic information already. There are some laws that are in the books, I believe in New York, already trying to prevent being prevented from certain aspect for loans, health insurance, according to your genetic profile. But as with anything, genetics aren't necessarily the Holy Ghost, right? When it comes to what you're going to be. Um, as we found with diet has a huge effect on your genome and turning on or off cancer cells. So if you just look at it from a genetic standpoint, oh well, you have the gene for this awful cancer, and so it's going to cost us $5 million to treat you. So go hump off. We're not going to give you insurance because of that. So there's already some laws on the books to try to prevent that, but there's some things that you are allowed to be profiled by and prevented from access to. So it's pretty interesting. So understanding this is something that is going to be important for the future. You take this diploid nucleus from the body and you basically shock it. It's got to be stimulated. It's got to be basically electrified. You electrify it to basically get it to divide a few times. And sometimes it takes several attempts to get this successfully accomplished. Sometimes it works, sometimes it doesn't. So taking that egg and getting it to start dividing is a pretty crucial step, because what do we need? I need a sperm and an egg, right? Well, if you can take a diploid egg cell and just utilize that whole information there and don't have any information from dad, I mean, I'm getting an exact copy of Mamacita. So that's going to be the point of it. There you go, 1996, mid 90s. Okay, probably none of you were born then, or just born. I don't know. They found this is where they started kind of understanding the concept of various different types of stem cells. You have, I think, 3 different types of stem cells, and depending upon the stem cell that is utilized, determines the potential outcome of said clone. And you can see Dolly only lived a handful of years here. There is adult stem cells. There are cord stem cells. And the stem cell research that's allowed here in the States primarily is the adult stem cells. And the adult stem cells have a much greater likelihood of negative outcomes, tumors, early death. It is the stem cells that are not allowed research here. I think there's only maybe 2 places here in the United States that are doing that kind of research, at least legal. I don't know about all the illegal stuff. I don't have any friends there. But that's a link. You can click on it. It was on Amazon Prime. That's where I saw it. That would have been something that we could maybe queue up here and watch a little bit of it. It's pretty fascinating and interesting. And there's a ton of research here from this place over in Russia. They have a ton of research out there online that you can look at. In the documentary, they give the website that you can go to. You can go there. You can read all their research. The doctor, I think, was his medical degree over here in the States, probably, like most of those. And then went over there to do his research and his work. And there's a bunch of people from the United States who have gone over there, and it's fascinating. Some of the debilitating diseases that these individuals were able to overcome. It's expensive, so it's not access to all. Oh, as you can kind of see, they've done a bunch of other things. Bunch of different species have done it. Horses, bulls, and goats. Those are some of the more successful ones, I believe, off the top of my head, that's been cloned. I don't know every single animal, though. You'd have to look that up online. What would be the potential application for this? Interesting. Why would somebody want to do this? Why would you make a clone of yourself? Well, I mean, it's materials, right? I mean, let's just call a spade a spade. It's material. It's material that I can use to, in case something goes wrong, I can just pluck off my copy and there we go. I blow I have some blown tendon, boom. Got something wrong with some kind of diseased organ. Well, I can harvest it out of my copy. If I had leukemia and I needed a bone transplant and a bone marrow transplant, I needed something really specific, couldn't find it. How awesome would it be to have my little garden? This is all highly disturbing stuff, right? But then who's to say, that copy doesn't deserve to live? Because you're going to have that conversation, right? And then what defines a human? See, this is like Pandora's box into the bucket of what if and what is and what does and how do we define it? So it's a very slippery slope, a razor's edge that you dance on when you talk about this. So for me, it's fascinating. I like kind of reading some information about it when it comes to this stuff. And if you get a chance to watch that documentary, if it's still on there, if you can find it somewhere, I'm sure it's somewhere on the internet for free. Fire stick it. It's just a fascinating discussion. Okay. These are the ones that have kind of the best ability to become. Excuse me. The reason why these things are such why these embryonic stem cells are so much better over some other types of stem cells is that they are pluripotential. Pluripotential is just a fancy way to say they can become many different things. They just a different hormone gets secreted or a different chemical gets secreted in the body, and that causes that cell to differentiate into this way, or it can be differentiated into that way. These can give rise to basically every cell in the body, these embryonic stem cells. These are the ones that they would like to use more of when it comes to in vitro fertilization, where you get the embryonic stem cells. You can do tissue-specific stem cells. They don't renew as well as compared to an embryonic stem cell. They have a greater chance of breaking down and degrading. That with Dolly, they saw that with that research and how they in the longevity of that animal. Excuse me. But they do a lot of work with tissue stem cells, and it's all that massive amount of research and work with tissue specific stem cells that has allowed us to kind of understand some of the applications with reproductive cloning, with replacing tissues by just I know back in the early 2000s, in the late 90s, they were growing, ears. They would insert that into the genome of various different laboratory mice, and they would inject that into a segment of the genome with laboratory mice that was associated with skin on kind of their dorsal aspect, and they were growing, just ears that you could then just cut off and then just replace when somebody had a massive burn or something that ate away at the pinna there, the external ear, and so you're able to grow body parts, grow a damaged tissue of on these various different animals. So there was a lot of benefit to this, even if tissue specific stem cells aren't really what you should utilize when you are trying to do reproductive cloning. Not that you're going to do reproductive cloning. I get it. But let's say you do someday. There you go.